This example is for practice with pre-processing the data based on some park data, survey data, to give us an example of going through a bunch of the stuff that we want to practice. So in this example, we have different features, the data type that we want to identify, and then details about this. And this was a survey done at a park to see if people would come back again, if they were satisfied, how they got there, things like that. So family, for this first feature or dimension or attribute, this is an ID. And so the details is just your identifier to keep track of each one uniquely. Now for time, this is going to be quantitative. So this is number of minutes. So this is a number of how long that they spent there. For travel, we have the different types of values you could have is walk, car, bike, or bus. So this is how they got there. So thinking through the different data types that we talked about, this would be a nominal type. Now for activity, again, this is also sport, picnic, read, walk. Now they can do multiple ones when they come to the park. And each one of these then there's no order to it or anything, so this one is also considered to be nominal. Now for satisfaction, we see -2 through +2 are the different values, and this is more of a ordinal value that they're selecting. There's order to it. And then for playground, whether or not it exists, that's a yes or no, so there's only 2 options, which therefore makes it a binary. So for park visitors, we've got the family, which is the identifier, A, B, C, D, the time, so these are in about 15-minute chunks, 30 minutes, 60 minutes, 45 minutes, how they got there, the different activities that they participated in, their satisfaction in the playground. So we only have an N of 4 in this example in our data set, just as a small example. Now for data conversion, so when we first look at these values for the family ID stays the same. The time, for now, it's already in a number, so it's already numerical, so we're going to keep it the same. Now for travel, how they got there, whether it's walk, car, bike, or bus, we are going to use the binary system to track which one it is. Since it's mutually exclusive, looks like we've got, for the first one is 0, 0 is for walk. So if we've got walk, we'll see the last person, D, also walked. So we're also going to put the 0, 0 in there as well. And then we have bike and car. We didn't use bus at all. So for a car, we'll do 0, 1. And then for bike, we're going to do 1, 0. Okay, so then for activities, we need these as numbers. So these, you can do multiple ones. So instead of using the binary 0, 1, 2, 3, 4, because they can select each one of them, we're going to look at each one of them as being like a binary variable. As far as did they do sport, and that would be 0 if they did not, and 1 if they did. Did they picnic? 0 if not, 1 if they did. And so we'll just do that for each one of them. And since there are 1, 2, 3, 4, 5, 6 options, sport, picnic, read, walk, meditate, jog, we're going to create this set of 6 binary values. So the first one, they did sport, picnic, and read, so we have 1, 1, 1, and they have 0, 0, 0 for the walk, meditate, and jog. So for the second one, they did walk and jog. So we're going to end up with 0, 0, 0, 1, 0, 1. All right, so we're going to continue and fill out the other two. Okay, then for satisfaction, we have values from -2 to +2. All right, so what we want to do now is essentially normalize them into values between 0 and 1. And so the first one was 2, which is a perfectly satisfied person. And so that's going to end up being a 1 because we just want it to be between the values 0 and 1. So then we have, there's another 2 in there, so we know that that's going to be a 1. And then we calculate for the 1 would end up being 0.75, and a -1 is 0.25. And of course, if somebody put in a -2, we would record that down as a 0. So with playground, it was either yes or no. And so those are strings, so we want to convert those to numbers. Binary is pretty easy, so with if the park does exist at that particular, a playground exists at that park, we're going to make that a 1, and if it doesn't exist, we'll make it a 0. And so playground yes is a 1, 1, 1, and for the one where it's not, it's a 0. All right, so now we have numbers for all of our attribute features that we want to work with. Now, when we're calculating the distance matrix, the problem is that with different data types, you cannot compute the distance on those different types. And so that's why we need to normalize, but normalizing coordinates are of still different types. So we want to calculate the distance for each feature as our solution. And so for quantitative, we can use something like Manhattan distance. And then for binary, we can use a simple matching distance. And then we'll normalize each of them, and then we'll end up with a single distance. And so on this next page, we have the Manhattan distance and the simple matching distance formulas. And so now when we're looking at time, is the first one, the formula that we're going to use is Manhattan for this one. All right, so here, if, for example, if we're going to use the distance between A and B, we have our table below here. So from A to B, we are looking for the absolute value, 30 minus 30, which gives us 0. So the difference between family A and family B as far as the time they spent is 0. There was no difference. So we're going to plug in a 0 here. All right, so then between family A and family C, there was a 30 for family A and 60 for family C. So we would have 30 minus 60, but it's the absolute value. So we end up with the value of 30. I'm going to fill in the rest of that table. Now what we want to do with that table finished, we have values that could be 0 up to 30, or we got 15 in there. We want to end up normalizing this so that when we compare time to something like their travel or satisfaction, that everything is an equally weighted value. And so what we're doing for normalization then, we're going to go between 0 and 1. And so we're going to look at the minimum value from our table. Well, we have a 0, and then our max value is a 30 in the distance table for time. And so what we can then do is to normalize it, we can say that the 0 is still 0, because we're going to go 0 through 1. 30 is our max, so that we'll put at 1. And 15 is halfway between those, so if we have a 15, it's going to be a 0.5. All right, so then I can fill out the table here. Between A and B, we had a 0, so that's going to stay 0. For B to C, we had a 30, so normalizing 30, we're going to end up with a 1. And then for the 15, we would end up putting the 0.5. Okay, so then for travel, for this one, we're going to use the formula for the Hamming distance, the Manhattan distance. And in this example, we have for D, the distance of A to B, so family A to family B. We're looking for those differences. So we have the 0 and the 0, and then we have the 0 and the 1. So we're going to end up adding 0 plus 1 to give us the Hamming distance between these two families, and that gives us a 1. So we can put a 1 in here. So for A to C, so family A and family C, family A 0, 0, and then family C was 1, 0. So again, we're going to do, this time it's going to be 1 plus the 0, which gives us 1 as well. All right, and we can go ahead and continue with this. For family A and family D, we can see that they, if you remember from the table on the previous page, they both walked, and so we have the difference is 0. All right, now again we want to normalize it, so we were doing it between the values of 0 and 1, so similar to what we did before, we're going to put these values in. All right, satisfaction. So originally we had between -2 to +2. We've already normalized it between 0 and 1. And so here what we want to do is look at the distance between family A and family B. So the distance there is 0.25 for this A and B. For A and C we have a 0. All right, so again, satisfaction, we didn't have to normalize because it's already in normalized values. We've already did the normalization between -2 to +2. We've already converted that from 0 to 1. And so all our values are between 0 and 1, so we're good. All right, so then the next page. So this just gives you even more practice with these values. So I'll let you go ahead and fill out these values. Again, for activities, we're going to use the Hamming distance and the Manhattan distance. So just like we did with the mode of travel, you want to figure out, well, what was different between those two families. So you're going to count up all the differences. So we'll go ahead and do the first one. So here, between family A and family B, there's a difference in the first bit. There's a difference in the second bit. Difference in the third bit as well. Then again with the next bit. Then we both, let's see, have a 0. So we end up with a value of 5 between family A and family B. All right, so you continue to go through and fill that out. And then normalize. Again, for normalizing, you're going to use the simple matching distance formula. And when you do that, just keep note that you have 6 different variables that you're dealing with. So, for example, between A and B, we would have 6 minus 1. So there's one match. So divided by 6. Gives us the 0.83. So that's how you know you're on the right track. And then you can calculate those values out. And then playground was already binary, so doing the distance between them is just going to subtract them. And then aggregate the normalized distance values. So here at this bottom table, and add up the values from the previous tables. So I'm going to fill out the normalized distance matrix, the aggregate, as well as normalizing those values, and you can use that to check to see if you're on the right track. All right, so I'm leaving blanks for you to practice and see if you can get to the right values. Just to clarify on the normalization one, so what you're doing is we're looking at, for example, when we have the 2.58, so we have the 2.58, what we're going to do is convert that, our values end up being between 0 and potentially 5. 5 would be the highest potential value. So what we're doing is we're going to take the 2.58, subtracting the minimum value that we would have in all of this, which is 0, divided by 5, which is the max, minus the minimum value, which is also 0. So those cancel out anyway, and we end up with 0.516, which would be rounded to 0.52, which is what we put in the table. So that's essentially what you're trying to do to get to this final table to see if you've got your answers correct. And then now what? What do you do at the end of all this? So this whole portion was working on the data and pre-processing the data and getting it ready to use for data mining. And so when you have different values, you need them converted to numbers and then normalized so that then we can do the data mining techniques on them. And so now we're ready to do whatever we want to do, whether it's clustering, we might do data reduction through either PCA, which is principal component analysis, or classification. And so those are the techniques we're going to get to later. This was just prepping the data to be able to use it in those techniques.